everybody, welcome back to Leetcode Simplified. I'm Alan and today we're tackling Leetcode 225 implement stack using queues. Yes, that's classic puzzle when we turn a queue into a stack. And guess what? We're going to solve it two ways, using just one queue and using two queues. Let's dive right in. I'm going to kick things up with the first approach using only one queue. It's simple, clever, and really elegant. First, initialize our stack with a Python's built-in queue to store all the elements of our stack. If we push 1, 2, 3 in and start popping out, the elements come out in order 1, 2, 3 because the queues are FIFO, first in, first out. Perfect for a queue, but a stack is LIFO, last in, first out. We need a clever way to reverse the order during the push operation to match stack behavior. Here's the clever trick. After appending new element X to the back of the queue, we rotate all older elements behind X. Let's append one to the queue. Then pop left all elements before one, then append them to the back of the queue. Let's push 2 to the stack. First append 2 to the back of the queue. Then pop left all elements before 2 and append it to the back of the queue again. Now let's try to push 3 onto the stack. First append 3 to the back of the queue. Then pop all elements before 3 and append it back to the queue. After this rotation, 3 is now at the front of the queue, acting at the top of the stack. If we want to pop our stack, it's super simple. Since the newest element is always at the front, we just pop front element. Want to know what is on top of the stack without removing it? Again, just return the front element. And if you want to check if the stack is empty, it's just a matter of checking if the queue itself is empty. See what's happening here? We've taken a queue with its standard operations append, pop left, and transform it to behave just like a stack. If we push 1, 2, 3 onto the stack, they come out in the order 3, 2, 1, exactly like a real stack. Okay, let's submit this version. Boom, accepted. Wonderful. That's how we implement stack using just one queue. Now let's step it up and see how we can implement the same stack using two queues. This approach is equally clever and it gives us another way to control the order of elements while maintaining that LIFO behavior of a stack. Let's first add a second queue, Q2. Q2 will act as a temporary storage while we reorder elements during push operation. Here's the same rotation trick but using two queues. First, push new element 1 into Q2. Then move all elements in the main queue behind X. In this case, we don't have anything here in the main queue to append to the back of 1. Then swap pointers Q and Q2. The main queue now has the correct stack order and Q2 is empty. Now let's push 2 onto our stack. First append new element 2 to Q2. Then pop left all elements out of queue and append it to Q2. Then swap Q and Q2 pointer. Let's try to put new element 3 onto our stack. First append 3 to Q2. Then pop all elements in Q and append it to Q2. And swap Q and Q2 pointers. Now the front of the main queue always represents the top of the stack, just like the one queue approach. The pop, top, and empty operations of our stack work exactly the same. If you want to pop the stack, just pop left the queue. And we're done. Alright, let's submit this version. Here's coming moment of truth. Boom, accepted. Perfect. The time complexity is constant big O of 1 for pop, top, and empty operations, and big O of n for push operation. The space complexity is big O of n for storing n elements in queues. That's it for today. If you found this explanation helpful, don't forget to subscribe and check out my other Leetcode playlist for problem explained simply and clearly. I'm Alan and this was Leetcode Simplified. Thanks for watching and I'll see you in the next video.